Today, we're going to break down some really urgent and incredibly important math, the world's remaining carbon budget. We're going to look at the numbers, what they actually mean, and why the timeline is, well, a lot shorter than you might think.
Okay, so let's just jump right in with the big question, the one that's driving this whole explainer. How much time do we really have left in our global carbon budget if we're serious about staying below that critical 1.5 degrees Celsius warming limit? And the answer, based on the rate we're going right now, is kind of shocking. As of 2026, the math points to roughly 3 years. Seriously, just let that sink in for a second. 3 years. Now, you're probably wondering, where in the world does that number come from?
Let's unpack it.
To really get this countdown, we first have to understand the finish line we're all trying not to cross. And that brings us to our first section. What is this 1.5 degree limit all about? So, what's the big deal with 1.5 degrees Celsius? You know, it's not some random number. It's the line in the sand that scientists have drawn to try and avoid the most severe, and this is the important part, irreversible impacts of climate change. We're talking about triggering tipping points, and we'll get into exactly what those are in just a bit. All right, so with that goal in mind, let's get into the nitty-gritty of the budget itself. How much can we still emit? And maybe more importantly, how fast are we blowing through it? Now, what's just wild about this slide is the acceleration it shows. Since the industrial age kicked off, we've pumped about 1,900 gigatons of CO2 into the atmosphere. But get this, a staggering 45% of all historical emissions have happened in just the last 25 years. It just shows you how much things have ramped up recently. So here's the crucial number. As of 2026, the total amount of carbon we can still emit while having a shot at staying under that 1.5 degree limit is just 130 gigatons. That's it. That's the entire remaining piggy bank for the whole planet. And here's the other side of that equation. This is how fast we're spending it. The world is currently burning through its budget at a rate of 42 gigatons of carbon per year. That's the drain on our account, happening every single day. And this is where the math gets really simple and honestly kind of scary. You take the remaining budget, that 130 gigatons, and you divide it by our annual spending, 42 gigatons. And what do you get? Yep, just a little over 3 years. It's stark, simple arithmetic based on the data. And, you know, that 3-year figure, it might even be optimistic. As this quote from the source material points out, some scientific perspectives suggest the window is actually even smaller. They're talking maybe just 1 to 2 years, depending on how you run the numbers. So, we've established the countdown. Now let's talk about what's actually at stake. What is the price of overshooting this very, very tight budget? Yeah, going over budget isn't just about the world getting a little toastier. It's about risking these huge, permanent shifts in the Earth's systems. We're talking about the methane bomb, a massive release of methane from thawing permafrost, the shutdown of crucial ocean currents like the AMAC that regulate our climate, mass coral bleaching, and of course, drastic sea level rise from melting ice sheets. And on top of those big tipping points, overshooting also means turning up the dial on the extreme weather we're already seeing. More frequent and way stronger storms, massive floods, widespread wildfires, and deadly heat waves, especially in equatorial regions where it can get so hot and humid your body literally can't cool itself down anymore. Now, what's really fascinating and a bit counterintuitive is how this warming creates a world of total extremes. As the oceans warm up, they evaporate more moisture into the air, and that moisture has to come down somewhere, causing these insane floods. But at the exact same time, shifting weather patterns are causing intense droughts in other places. So you end up with a world of too much water and not enough water, all at once. And get this, here's another paradox for you. Global warming can cause extreme cold. The source material explains how the jet streams in the atmosphere can get all wobbly and disrupted. When that happens, it can drag the polar vortex way farther south than usual, blasting regions with frigid Arctic air that they are just not prepared to handle. Okay, so this brings us to our final section, and it's a really crucial point. This isn't just a simple linear countdown. It's actually an accelerating problem. So why is it speeding up? First off, carbon dioxide doesn't just disappear. When we put it up there, it hangs around in the atmosphere for centuries, meaning the emissions from today will continue to warm the planet for generations to come. And second, and this is the big one, we risk triggering these dangerous feedback loops. A great example is the methane feedback loop. It's basically a chain reaction.
Step 1, we emit greenhouse gases. Step 2, the planet heats up. Step 3, that warming thaws out frozen ground and ice. Step 4, this releases enormous amounts of methane that were trapped inside. And here's the real kicker, Step 5, that new methane heats the planet up way faster, which in turn melts more ice. And you see how the cycle just starts feeding on itself.
So that's the math, and those are the stakes. And it brings us right back to the central tension of this whole thing. The carbon budget is nearly spent. The clock is ticking down from just a few years. And it leaves us with one critical question to think about. What happens when that clock hits zero?